Hi, everybody. Okay, now we're going to do the first experiment with the pendula coupled together. So I'm going to take this spring, and we'll couple the pendula together here, 10 centimeters below the pivot point. So that corresponds to weak coupling. And then we'll get them started. Now you know that when the pendula are coupled, that there are two modes of oscillation. A symmetric mode, where the pendula move together, and an asymmetric mode, where they move in opposition. Now, what we're going to do is to set up a measurement where we're in a superposition of those two modes. First, because it's going to look really cool, and secondly, because it'll give us all the data that we need. We'll see both frequencies in the data that we collect. So that's what we're going to do. To do that, we're just going to start this with one pendulum in motion and the other one at rest, like so. There we go. Notice how when we start out, one pendulum was at rest, but as we proceed in time, the amplitude of motion transfers from one pendulum to the second one. And then if you keep watching, it'll transfer back. Oops. They're not supposed to slam into each other like that. Okay, I think everything's fine now. Let's start collecting some data. I'm just going to change the scale on the graph a little bit so you can see what's going on. Ah, there we are. Can you see that? I hope the both the upper and the lower traces are clear. But you can see the amplitude of one decay while the amplitude of the other grows, and then it switches back. Meanwhile, you can see the same thing in real time, looking at the actual motion of the pendulum. So let's look at that for a few moments, and then we'll just let the system collect data and take a look at what it looks like at the end. Okay, so far, the beating in the amplitudes, I think, is very clear. But we don't yet see exactly what we want, what we'd like, which is the two distinct modes clear in the Fourier transform data. And well, we'll see if we see that by the end of the acquisition. Okay, I think we'll skip ahead to the end now. Okay, well, the data acquisition is complete now. I've rescaled the screen so you can see all of the data, and you can clearly see the beating between the symmetric and anti-symmetric mode. Of course, the beating is present in each of these files. The red one is just showing the motion of one pendulum, and the blue one, the motion of the other. Finally, if we look at the Fourier transform data, now you can see two clear peaks, both in the amplitude pendulum 1 and in the pendulum 2 data. Actually, they're just on top of one each other. But there's a lower frequency mode, which is the symmetric mode, and a higher frequency mode, which is the anti-symmetric mode. Pretty neat. Okay, let's pause for a second, and we'll set up the next measurement. Okay, well, now we're ready to set up the second measurement. Oh, let's see here. There we are. And to do that, we just place the coupling spring on the second set of holes, like so. Actually, I think I want to put this into a separate video. 1 second.